Hello friends, welcome to Electronic Circuit Hub. So today we will understand operational transconductance amplifier. It is called OTA, right? It is called OTA. So we will see the the symbol of OTA, operational transconductance amplifier, the basic operation of OTA, the basic circuit of OTA, the real-time application of operational transconductance amplifier, and we will see some practical operational transconductance amplifier part number, right? So all these things we will see today. So this is the symbol of operational transconductance amplifier, right? Operational transconductance amplifier, that is OTA, OTA, OTA. So this is the symbol of operational transconductance amplifier. You can see uh, this is op amp, this is input terminal, this is output terminal, this is I bias terminal, right? So what is operational transconductance amplifier? The operational transconductance amplifier is a voltage to current amplifier in which output current is equal to the gain times of input voltage. Okay, the output current is equal to the gain times of input voltage. Sometimes it is also called voltage control current source. Okay, operational transconductance amplifier, sometimes it is also called voltage control current source, right? So the double circle in the symbol represents an output current source that is dependent on the bias current, right? This the double circle represent the current source, output current source, and this current source is dependent on bias current, that is I bias, right? OTA has two differential input terminals. It has two differential input terminals, a high input impedance, okay, a high CMMR bias current input terminal. This is the bias current input terminal, and high output impedance, and it has no fixed open loop voltage gain. So these are the some basics points regarding operational transconductance amplifier, right? So the transconductance is the gain of OTA. The transconductance is the gain of operational transconductance amplifier. How? Let us see. The transconductance of electronics device is given by the ratio of output current to input voltage. The ratio of output current to input voltage. So GM equals to I out divided by V in. Okay, where GM is transconductance. So transconductance is given by the output current divided by input voltage. I out divided by V in, right? In OTA, the transconductance is dependent on a constant K times the bias current I bias, and the value of K depend on internal circuit. So you can see GM, the transconductance is given by K into I bias. So from this equation, I out equals to GM into V in. Okay, so I out equals to GM into V in. If you replace the value of GM, K into I bias, you will get K into I bias into V in. So this is the I out. So you can see by this equation, I out equals to GM into V in, and it is equal to K into I bias into V in. So the output current is dependent on the value of I bias and the value of input voltage, right? So the output current is controlled by the input voltage and the bias current, right? So this is the basic circuit of operational transconductance amplifier. You can see this is input voltage which is connected at inverting terminal. This is R2. This is positive supply V plus. This is negative supply V minus. This is double in circle which represent the current source. This is R biasing resistance, and this is I bias current flowing through this resistance is I bias. This is the I load RL, and this is the load current, right? So this output current is depend on the value of bias current and the value of input voltage. So how do you fix the value of bias current? Sometimes people use a a variable register here to fix the value of I bias, and sometimes people used a separate voltage source here. Okay, let us say V reference to fix the value of I bias, right? So hope you understand the operation of operational transconductance amplifier, that is OTA, and how it looks like, what is the symbol, how what is the transconductance, and what all parameters need to be taken into account to find the value of I out. Okay, we have already seen in the previous slide. Okay, so this is I out equals to K into I bias into V in, right? So now we will see the application of transconductance amplifier. So basically it is used in amplitude modulation, okay, in the communication system. If you want to find out some practical part number of operational transconductance amplifier which are already available in the market, so these are some parts taken from the Texas Instrument OPA 861 and OPA 615. You can download the data sheet of OPA 861 and OPA 615 and see what all parameter given for operational transconductance amplifier, that is OTA. So hope you understand the basics of operational transconductance amplifier. If you have any question, feel free to ask me in comment section.